Hi everyone. First of all, thank you for inviting me to great seminar. Today I'd like to talk about my research topic. So actually, I just changed my research title. So this is the AI seminar. So what I'm trying to say today is AI-powered diagnostic with SWIM deep convolution neural network. SWIM stands for multi-scale, multi-level mass DCNN. So this is applied for our smart diagnostic robot for pepper inspection of underground power tunnel system. So I will start with what is the motivation of my research, and then I will introduce our smart diagnostic robot, and then we will discuss about two case studies, such as threat detection in underground tunnel system or anomaly detection in power transmission line. And then I will finish my presentation with a closing remark. Let's start on motivation of this research. So object detection play a critical role in many applications, such as autonomous driving, autonomous flying, surveillance camera, etc. But there are lots of accidents, such as Tesla autopilot or autonomous flight, because of the absence of the cognition. So what it means? It means that high accuracy of object detection should be secured to mitigate the many concerns on application. Right? So there are two kinds of models in object detection. One is the one-stage model, and the other one is two-stage model. So one-stage model uses the parallel connection of localization model and classification, whereas two-stage model use the serial connection of localization and classification. So once you see this kind of two architecture, you clearly imagine that one-stage model is faster than two-stage model, right? However, accuracy of the one-stage model would be less than that of two-stage model. That is sort of clear understanding, because that is basically originated from the architecture. But so actually there are trade-off between the speed versus accuracy when you use which kind of model. But nowadays one-stage architecture is in the center of attention, because object detection is normally applied for real-time application. So there are many kinds of one-stage models in the is published nowadays. So the one of the famous one is signature detector. So they detect objects through multi-scale feature map. So and the other one is Euro series. So Euro stands for you only look once, and Euro detect the objects to the multi-scale feature map with upscaling and residual connection. So actually this is sort of autoencoder structures with residual connection, and thereby they increase the accuracy. And then one of the famous one is M2DET. So they detect objects through multi-level pyramid feature pyramid network. So multi-level stands for they use the deep neural network, and feature pyramid network means stands for multi-scale. In other words, multi-scale and multi-level feature map nowadays secure the accuracy and robustness. So that is the trend of the research in object detection. So why multi-scale and multi-level architecture is effective? Actually, this figure clearly shows this figure is the activation map of the example. And this one clearly shows why multi-level and multi-scale architecture is effective. So there are three kinds of object interested in. One is traffic sign, second one is car, and third one is pedestrian. So when you see the traffic sign, we can imagine the shape of a traffic sign is a little bit simple compared to others. And size is small. Actually, yeah, we for the large size one, yeah, it is easy to recognize, so we can skip it. So when you see the traffic sign, yeah, as you can see here, that topic that is very easily extracted in the low-level features and high-scale features. So that might be the reason that we can see those kind of thing in low-level and high-scale features. And for the curves, yeah, they are medium size shape and small size, and thereby they are easily activated in medium level features and high scale features. Yeah, what about the pedestrian? Actually, pedestrian might be the most complex compared to other ones. So as you can see in activation map, we can extract the feature in high level and high scale maps. So it means that multi-scale and multi-level architecture increase the accuracy and robustness for small and complex shaped objects. That is quite clear. And the other important method is masked regional convolution neural network. So masked neural network is better than bounding box because they did not worry about the feature extracted from the background. When you use the bounding box, you can extract the many features even in bounding box, and they destroy the accuracy and robustness, especially when you use your data for the different working condition. But when you use the mask, yeah, you just extract the feature from the masked object of interest, and thereby, yeah, it significantly increases the accuracy and robustness. Yeah. So mask outcome from the bounding box involves accuracy and robustness, but the problem comes there is the significant effort are required on labeling when you use a mask. Yeah. So our basic idea for our research is that what about we can replace the bounding box in multi-scale and multi-level neural network to mask? Yeah, we believe that that might be effective to increase the accuracy and robustness. Yeah, but it holds the speed of the one stage of the neural network. That is the basic idea of the today lecture. Yeah, so we developed the smart inspection robot Docker. So this is the targeting system, underground power transmission line located in kernel. As you expected, there are many kinds of failure in the power transmission line. So we have to develop a diagnostic method for power transmission line. And the other problem is that tunnel suffer from crack, water leak, etc. So we have to also develop a structural health monitoring method for tunnels. And last problem is that there is GPS information in here, and thereby we need a 3D localization method. But I will not talk about those kind of things today because this is out of the task in today's lectures. And we believe the AI-powered PHM have to develop a diverse method and structured method. So we will discuss about those kind of things later. So we developed an integrated inspection system combining 4K camera, IR camera, LiDAR sensor, gas sensor, etc. with customized lightweighted timber. And one of the important things to develop this kind of thing is compatibility. Yeah, that can be mounted on any mobile robot. So we think about what kind of mobile robot might be appropriate for underground tunnel system. One is the field-based rover, and the other one is field-based mechanoid rover. Yeah, and third one is a full-legged dog. Yeah, and as you can see here, yeah, we developed this integrated inspection system considering the compatibility, so it works in any kind of mobile robot, but because of the several obstacles in the underground tunnel system, we decided to use the four-legged robot, as you can see here. So this is the field test video. So our robot moves through the underground tunnel and measure the data. So actually there is no problem to monitor the system underground tunnel. So we also developed a three novel diagnostic method. Two is for structure monitoring in tunnels, and one is for anomaly detection in power transmission line. But I will just talk about one for structure monitoring and one for anomaly detection that is closely related to AI-powered PHF. So the first thing is crack detection in underground tunnel system. So this is the overall architecture of our algorithm of the crack detection. But the most important thing is that we can embed the 3M deep convolution neural network, and other post-processing method is eliminating non-crack features. So as you can see here, we construct the multi-scale, multi-level mask detection model. Yeah, and one of the important things is that we train our 3M deep convolution neural network through public image set. One of the important assumptions in here is that crack is a very unique features, and thereby we can train our neural network through the public data set which was measured from over the world. Yeah, it actually works in our system. So we trained our neural network by using the three image set of this kind of one and train test the stone 331 image sets. This is the one of the example, but yeah, I'm not sure whether you can clearly see. So this is the actual table, performance comparison of the table. Yeah, so as you can see here, Mascara CNN shows a very lowest prediction accuracy, and Resident UNet also shows a better good accuracy, and yeah, multi-scale mask deep CNN with 3-scale and 4-scale shows the marginal accuracy, and 3M deep convolution neural network, multi-scale and multi-level mask deep CNN show the best accuracy because of the deep and complex shape of the neural network. But this one clearly shows that this is also limitation because frame per second calculation speed of the 3D deep convolution neural network is slower than others. So if you think that this is not enough for your application, I recommend to use the other network. Anyway, this is used for the structures monitoring method, structures monitoring. So that is enough for our implementation. So we use the 3M deep CNN in our application. Yeah, but what is the problem? We apply for this well-trained neural net in the real-world application, and interesting thing is that this one clearly recognize the crack, as you can see here. But the problem is that our neural net also predict the non-crack features such as this kind of type in here. But as you expected, this looks very reasonable because these line features are very similar to crack features. Yeah, that is exactly the same in the underground tunnel. Yeah, our neural net predict the crack features as well as line features. Yeah, so we also developed the method to eliminate the line features. Basic idea of the method, proposed method is very simple. Crack would be the more curved linear shape compared to line picture. So we develop or calculate the area of the each line picture, predicted picture with respect to principal axis, and then that is the first term in our line similarity index. And then second one is that how many times this curvilinear picture meet the principal axis. Yeah, that would be one of also good indicator to separate the correct picture with the non-correct pictures that is in this here in our line similarity index. So when we compare the line pictures and correct pictures and non-correct pictures in probability distribution by the line similarity index, as you can see here, they have a clearly separation in probability distribution by using the 3 sigma method or outlier detection method. So it means that once we use this line similarity index, we can separate or eliminate the non-correct features from predicted mask. So we do some sort of image processing method, risk for time limitation, but this is the result. So as we mentioned, our neural net predict any kind of curvilinear features. And when we apply the line similarity index, many kind of line features are eliminated. Yeah, that is the same in both indoor and outdoor applications. And this is quantitative two metrics. So the first metric is how the feature should remain after applying the linear similarity index. So as you can see here, the accuracy is around 80%. And the second metric is the feature which should be eliminated is how much eliminated. So that is also, and the total reference score to ensemble is around 80%. So it means that 80% of the accuracy is guaranteed by using the line similarity index. Absolutely. I believe that this is not enough accuracy, and we need more research to increase the accuracy. But what I'm trying to say in here is that, deep neural network effectively predict the mask, but that is not at all. Yeah, for the real-time application, you might face the many kind of situation, and you also have to develop the other methods to increase the actual feasibility in real-world application. Second one is anomaly detection in power transmission line. So this is the overall structure of anomaly detection with the IR camera data. So in the first page A, we use the multi-scale deconvolution neural network, and then we eliminate some sort of noise data by using the image processing method, and then finally, we use the outlier detection based on the temperature difference. Difference following by the regulation code. So let's talk about first page. So in here, we use the multi-scale mask deep CNN network because the telescope in here is too simple. What I'm trying to say in here is that we put this image as an input, IR camera data as an input, and then we want to eliminate the background from the because actually our interest is the power transmission line. So these two deep convolution neural network is just used as a filter to detect the power transmission line. But AI is not perfect. There is no perfect system in here. So when we see the predicted data, we realize that there are some sort of unexpected data. The reason is simple. Actually, our neural network is trained by the IR camera, and then the baseline, supporter of the power transmission line make some sort of a summer reflection. So those kind of data is tokenized as power transmission line in here. Yeah. So we use the contour method to eliminate those kind of things, and then finally we use this filter to IR camera to just see the power transmission line, and then we do the probability analysis by using the 3 sigma and 6 sigma and do the anomaly. Yeah. So we train our data system by using the static data, as you can see here, and then validate by using the dynamic data. Yeah. And this is a performance. Yeah. So as you can see here, we do the 3 scale and 2 scale, and then there are lots of resolution, different resolution. Yeah. And actually, I did not include the 3MD convolution network, but the accuracy is very similar. So actually, when we do not apply the contour method, accuracy is a little bit slower, but we effectively eliminate the summarized reflection effects through the contour method, and thereby accuracy is increased. And the interesting thing is that when we change the scale, resolution of the input data, that is not significantly affect the prediction result, which is the result. As I mentioned, the mission is too simple. That might be the reason for this kind of thing. But anyway, the accuracy in this order, frame per second is very dependent on the net architecture of the network. So which one is better? It totally depends on you, your purpose. But we thought that this might be the best thing for real-time application on the mobile level. So we selected this one as the final one, and then this is the final monitoring method. So this is the ground truth, and this is the original data. Our 2M deep CNN effectively extract the power transmission line, and then based on this thermal distribution, we can estimate whether anomaly exists. And as you can see here, there are some sort of anomaly in here. What is this? Actually, it's me. My student did the experiment at that time, and I was in front of the power transmission line. And IR camera measured my temperature. Yeah, in here. Yeah, and there are several portion around in here. Actually, that is some reflection of my temperature data on the supporter of power transmission line. So actually, that was the wrong experiment. We tried at that time. We thought that this should be eliminated, but yeah, at this time, this is a very good demonstration of anomaly detection. Yeah. So I will finish my closing remark. The first one is 3M multi-scale multi-level mask deep CNN. So as I mentioned, complex and deep neural network secure the high accuracy and low smoothness. But yeah, labeling masks require the heavy effort for training neural network. So there are trade-off. You have to select which one is better for your mission. And so yeah, and then as I mentioned, for the simple test, 2D might be enough. But if you want more accuracy, 3M, multi-scale, multi-level mask might be appropriate for your application. And then, yeah, I believe that AI can be used a different way in PHM. So in crack detection, we use the AI, directly use the AI for the PHM. But in the second case, we use the just AI as a filter, so that totally depends on your application. And in both the case studies, AI has a limitation. So you can do the apply the domain knowledge, signal and or image processing method to overcome those kind of limitation. That might be the reason that you are in here. As a mechanical engineer, you can apply your domain knowledge to overcome the limitation of the AI. Yeah. And last one is mobility. Yeah, I believe that AI, synergy effect of the AI on mobility and PHM. So for final goal is that we want to develop a fully autonomous inspection system in that scope. Yeah, PHM theory, mobility, AI, all of the principles should be converted to for achieve the milestone. So thanks for the listening, and this is the end of my presentation. So if you have any question, yeah, please do not hesitate.
Thank you very much for your excellent presentation. I think we have a Q&A session, 1 or 2 questions. Okay, first of all, let me ask a question. So for your anomaly detection part, actually anomaly means anything except normal. So in that case, after you detect some anomalies, how can you process? What is the after processing things?
It means that if we detect the anomaly, what is the next step?
Right.
Yeah. Actually, that might be the first. That might be the very great question. In general application of energy field for PHM, normally this kind of inspection robot do the patrol inspection. Yeah, because we don't know whether that is finally in the fault condition. So patrol inspection find the anomaly with their location information, and then many kind of special expert system do the precise inspection to decide whether system is failed. Yeah. So patrol inspection just want to do find the anomaly, and finally sports system play a critical role in failure. Yeah, I think that might be the reason that all of your this student is in here. Yeah, your domain knowledge is finally make the decision.
Okay, so for anomaly detection, you just conduct ordinary inspection. Maybe regular basis, and then if you find something wrong, you send the person or maintenance technician.
Yeah, exactly.
Any other question? On the online, you can ask. You can leave a message on the chat, or you can directly ask a question. If you have any question. Any question from the student side? Maybe it's so hard. Lunch time, so you have to proceed. Okay. Thank you for your excellent presentation, and I really appreciate it.